Hello and welcome to another tutorial. We're going to continue our discussion on how to work with the platform default toolchain. And previously we looked at the macOS default toolchain. We said that it's a Apple Clang. It's a proprietary compiler that Apple provides. And then all the aliases on the terminal, which is C++ or G++ or Clang or GCC, they all point to the same bin directory, which is basically the Apple Clang, and then that's the C++ compiler, right? And then next we're going to look at the Linux Ubuntu, which is my favorite Linux distro. It's very easy to work with and it has a very nice terminal. And the platform toolchain, obviously Linux is open source and you expect that the toolchains that come with it are also open source. And I believe Ubuntu by default comes with a toolchain, which is its default toolchain, which is the GCC GNU compiler collection, right? And it's open source. You can install it, customize it, and the easy ways to install it. I believe Ubuntu comes by default with GCC, the GNU compiler collection. If it doesn't, you have to install the build essentials for Linux. So in order to basically install the command line tools in terminal or basically install GCC, you first update your application repository cache, and then sudo apt install build essentials. You have to run it in the super user mode, so you need to have super user privileges. If you're not familiar with Linux terminal, basically whenever you run a sudo command, you have to provide administrative password. So this is more like administrative privileges. You have to have that. And then apt is the command line executable binary application in Linux that manages your basically application cache from the remote repositories. And again, just like macOS that has an online app store, Linux also has repositories that the operating system can connect to them and download the applications and then install them on your operating system on your computer. And this apt is basically the application that manages that. Install is a command line argument for this apt, and then you tell it what you want to install. And build essentials. Now if you want to learn more about build essentials, you can go to this basically internet address. It's fast.com build essentials Ubuntu, and that gives you a lot of information about what these build essentials are and how to install them. It's very easy. As you can see, I have it here. You just say sudo apt install build -essential, right? So check if build essential is installed, and the first time you run it, the way the apt works, it always updates your repository list first, the packages, and then reading state information. Build essential is already the newest version, and basically when you run this install command, if you haven't installed it, if your Linux distribution doesn't come with this build essentials, then apt goes and grabs the files and download them and install them on your computer. If basically you've already installed them, apt checks if you have the latest version. If not, it tries to update your version. Mine says build essential is already the newest version. The following packages were automatically installed and no longer required. So it also tells you which packages are deprecated or they don't have any other application that rely on them. Use sudo apt auto remove to remove them. So you can tell apt application with the command line argument auto remove, and apt goes through all the caches and then of your application and see which ones don't have any other applications rely on them, and then you can delete them. All right, and then after you do this and install this build essential, you can check whether you have GCC or G++ arguments there, right? So which GCC, and it says it's user bin GCC, right? Which means it's the terminal is able to locate the compiler, the C compiler GCC. If you type G++, it's a C++ compiler, so you have to check that. And then you can also type GCC -- version. So first of all, you should be able to check whether the terminal can locate the GCC executable, and it's usually in the user bin GCC, and the files or the references in the user bin are usually basically symbolic references or shortcuts to where the actual file resides. I mean, to the operating system or the terminal, there's no really difference between a symbolic reference and an actual executable. And then you can also check which version of the GCC you're using. You just say GCC hyphen version. GCC is compiling C source files by default. G++ is compiling C++ or CPP source files by default. And again, these days we don't really care that much about C. We only care about modern C++. So I'm going to head to Linux and quickly show you this. So here's my Linux. Let me just log in. I'm running it in a virtual machine. Ubuntu is very easy. And here's my terminal. And as you can see, just like macOS, I'm very fond of this fish application, which stands for Friendly Interactive Shell. You can, if you don't know how to install it, you just can say probably sudo apt install fish, for example. That should be easily installed. And I've right now I'm in my home directory. If I look at my bash rc, you see that at the end of my bash rc I have this command to run the fish. So whenever you launch the terminal, it executes or loads the bash profile file, and then in the bash profile you can source your bash rc. And in the bash RC, I usually want at the end to define all the global environment variables, and eventually I want to run the fish, friendly interactive shell, on top of my original terminal. So if you look at the bash profile, let's see if we have a bash profile file. So we don't have it. So right now we're just loading the bash RC directly. In macOS, I think it loads bash profile and then you can source bash rc. Here, I guess it just loads bash rc directly. All right, so we are there in my virtual box, Linux Ubuntu, and then sudo apt basically install build essential. And you want to run it in a super user mode so that you do have administrative privileges, because it has to access the root directories. So let's put the password, and it says build essential is already the newest version, 0 upgrades, 0 newly installed, 0 to remove, 546 not upgraded. So it says me that you've already installed it. If you haven't installed it, you just type this and it automatically grabs it. And then what we want to do, we want to check whether we have access to the compilers, which is the build default toolchain for building applications, right? You have to compile to the native binaries. Native binaries depend on the operating system and then the CPU architecture instruction sets. And when you run VirtualBox, what you can do, a virtual machine also basically you mimic the same CPU architecture, right? The processors that this sees is kind of like a virtual processor, but they have, for example, my computer has a 64-bit Intel CPU, so the VirtualBox also assumes that it has the same instruction set. So I'm going to say that which GCC, it tells me it's in the user bin GCC, and then which G++, it tells me it's in the user bin G++, and then I can say GCC hyphen version, and it tells me that it's basically it's available. This is the version that comes with Ubuntu, and then G++ hyphen version, and it tells me that this is a G++ compiler, etc. Now, the last thing that we want to do to make sure that all of the build tool chains are fully installed and ready to go for us to basically compile a Java application to native binary is to just write a simple C++ hello world and then try to compile it, make sure everything works fine. So I'm going to cd in my desktop, and then let's create a CPP file. So we can say touch. Touch is a command that just creates an empty file. Hello.cpp, and as you can see, it's here on my desktop. I'm going to open it with a probably text editor. Let's see what we have. We have this text editor here. So I'm going to open a on my desktop, I'm going to open up this helloworld.cpp. Let's see if we can zoom in a little bit. Okay, so let's write the typical hello world. So we're going to include basically IO stream. All right, and then we're going to say that int main. We saw that right now my application is not going to request any take any command line arguments, so you can leave it. You don't need to pass the argc and argv because we don't care about them. And then we're going to say that stdcout hello world from C++ application, and then we push a /n and then semicolon. We don't need to type return 0, that's fine. So we save this, and here we're going to clear and then say g++ hello.cpp, and let's call the output file name or the compiled file as my app. And it tries to compile. Let's see if, and then there is no error, all the compilation is successful, and we have a native executable binary called my app. And again, similar to macOS, if you want to execute it and the application, you have to give the relative path or the full path to this executable file in terminal. Right now I'm in the same directory, desktop, so I say from current directory execute my app, and we can pass basically command line arguments, but they're going to be ignored because we're not capturing any argc or argv here. So hello you are, and then it just runs the application, whatever is inside the main method, and then it terminates and it disregards any strings that come after the name of the application because we're not capturing any argc or argv, right? Now obviously we can do that if we say int argc and then char array argv array, right? And then we can go through them, just print the exactly like what we did in C++ in macOS. Just make sure that everything works fine. Print command line arguments to the terminal again. So we know that what we do is basically for int or size t, both works fine. Size t I equals 0, I less than argc, I plus plus. We're going to say that std cout argv at index I, it returns a char star or basically a string, and cout, this overload insertion operator is overloaded, so it knows how to handle the char star. And then we're going to do a \n new line to the terminal, right? So save, we have to obviously compile again. Everything works fine, and now we run our application, and now we know that in C++ for the C++ application, the number of arguments are like you have the command line arguments and also the name of the application, relative or absolute path. We saw that in macOS, the same story here in Linux. So the first argument or the first string in this string array is always the name of the application, whatever exactly what you type here, and then hello you are. So basically these are the command line arguments. All right, so everything works fine, our tool chain is successful. Now note that if you try to compile with GCC, so basically what it does is that it now complains because GCC considers C source files, not C++. So it says, I don't know what this std cout is. These are undefined. So because when you run GCC, it uses the header files that are associated with the basically C, not C++. And in C, you don't have any objects, any std or any namespace. But when you say g++ hello.cpp-o try, it works fine, right? And if we now say try, it also works fine. Now we only have one argument as the command line. All right, I hope you enjoyed this lecture, and basically next we're going to look at the Windows, and I quickly show you how to set up the default tool chains in Windows. Now Windows is a little bit more complicated because you have to go and download it's not really about the terminal. You have to basically download the Microsoft Visual C compiler separately, install it. Now whenever you install something in macOS and Linux using the terminal, especially in Linux, they already basically set up the path environment variable so that all these, for example, compilers are already available on the terminal. You don't need to write, for example, the absolute path to those executable binary. Now in Windows it's not the case, so we have to do some extra work to set it up. So yeah, so next we look at Windows.